So in this question, we have this thermodynamic system. It's taken from a state A to state B to state C, and then back to A as shown in the PV diagram here. The vertical axis is set by PS equals 40 Pascal. So this is PS over here. And the horizontal scale is set by VS equals 4 meters cubed. We want to complete the table by inserting the sign of each indicated cell. The cells contain the heat, the work done, and the change in internal energy. And finally, we want to find the net work done by the system as it moves once through this cycle ABCA. So if we look at the table, we're interested in the sign only. Let's remember that we know that if we have a closed loop, we can expect that the change in the internal energy total is equal to 0. If the loop is anticlockwise as we have here, this tells us that the total work is going to be negative. And we can just now check the different stages of this loop. The first process from A to B, we are given that delta E internal is positive. Now, if we look at what we have here, this is from A to B. We can see first of all that the volume is increasing, and this tells us that the work done should be positive. And we know that Q is equal to W plus delta E internal. If both of these are positive, then Q is positive as well. So the answers would be for part A, positive, for part B, also positive. We might write these as signs. Now, if we look at the second process from B to C, we can see that this is a process at a constant volume, which means that we have no work done. We are given that Q is positive, so we also know that Q is W plus the change in internal energy. If Q is positive, then delta E internal will be positive as well. So the answer here would be, for part C, this is the work done, it is 0. For part D, this is the change in internal energy, and it will be positive. If we look at the third process, which is from C to A, so from C to A, you can see this is our process. Now, we are not given anything related to this process, but we can see that the volume decreases here, which means that the work is negative. So if we look now at the other variables, we still need to think about Q and the change in the internal energy. If we check for Q, all we know is that Q is equal to W plus delta E internal. W is negative, but we have no idea about the other component, which is the change in internal energy. However, we just wrote previously that for a closed loop, delta E internal equals 0 for the whole loop, which means that delta E internal from A to B plus delta E internal from B to C plus delta E internal from C to A should be equal to 0. Now, if we look at the signs of the change in internal energy, from A to B it is positive, from B to C it is also positive, so from C to A it must be negative, so that the net change in internal energy is 0. Now we know that Q is W plus delta E internal. We said W is negative because the volume was decreasing, and we just found out that the change in internal energy in this process is negative as well, so Q is negative. So now we can write for E, this is negative, negative, and for part G, this is also negative. Now, in part B of this question, we want to find the work done. Sorry, this is from A to G. This is part H. We want the work done by one loop. So we want the work done from A to B to C and back to A. And of course, this is equal to the area enclosed by the loop, which is the area of the triangle ABC, which is going to be the height times the base over 2. We can see the scales now in order to determine the height. So this is the height of our triangle, it's BC itself. The scale here is set by 40 Pascal, which means that each division is 10 Pascals. So the length from C to B is 20 Pascals. From A to B, we can see that the horizontal scale is set by VS, which is 4 meters cubed, which means that every division is 1 meter cubed. So from A to B, we have 2 meter cubed. So we can write now the height, which is 20 times 2 over 2, and this gives us 20 joules. This is the value of the work done.